3, 2, 1, go. All right, now we're going to do part B of the lesson. This one we're going to work on really the last kind of two objectives for chapter 7.1. We're going to look at multiplying rational expressions and then dividing rational expressions are what we're going to look for this one. So in the last lesson we talked about what those rational expressions were, the numerator and the denominator are polynomials. And we worked on simplifying them. And that's really going to be the key to both multiplying and dividing, is being able to simplify. Because once you can multiply and divide, once you can simplify, multiplying and dividing really isn't too bad of an operation to do with these. So some helpful hints when you're multiplying and dividing. Step one, you're going to factor out all numerators. Factor all numerators and denominators as completely as possible. So factor, factor, factor. That's going to be a big key in today's stuff. Apply the fundamental properties. So if you can reduce, reduce. Then you're going to multiply factors in the numerator with what's in the numerator and the remaining denominators with what's remaining in the denominator. And then you can always check to make sure things are then in lowest terms. So factor first, reduce anything you can, top times the top, bottom times the bottom. Step one, step two, step three. Step four is check. Okay, so we're going to go ahead and do a couple of examples. So we're going to multiply. So when you're multiplying, factor everything. I mean, if it can be factored, you factor it. So I look at each numerator and each denominator, and I factor it. So if we look at A, c squared plus 2c, two terms. So I look for a common factor. They've got a common factor of c, so I'm going to factor a c out of there. So if I factor out a c, that leaves me with c plus 2. So I took care of that numerator. If I look at the denominator, c squared minus 4, it's a difference of squares. So the square root of c is c, the square root of 4 is 2. So it's c minus 2, c plus 2. So the first one is factored. Times. I'm going to factor the second set. I've got a trinomial. So since it's a trinomial, I have to do the x thing. 4 goes on the top, negative 4 on the bottom. So negative 2 and negative 2. So it's c minus 2 times c minus 2. On the bottom, two terms. Two terms, I look for a GCF. GCF is c, so I take out a c. I take out a c, that leaves me with c minus 1. So now I've got everything factored. Now I'm going to look at applying the principle. If something is in the numerator and in the denominator, they're the same exact thing, I can go ahead and divide them out or cancel them out. And it doesn't matter which numerator they're in or which denominator they're in. So for example, there's a c minus 2 here. I can cross that out or cancel that out with that c minus 2 right there. They don't have to be in the same one. They can be in different ones as long as one's in the numerator and one's in the denominator. Okay, I've got a c in the numerator here. I've got a c in the numerator there. They're going to cancel each other out. I've got a c plus 2 here, and I've got a c plus 2 there. They're canceling each other out. Now I look and see what's left. The only things I have left are c minus 2 and c minus 1. So then that's going to be my solution. C minus 2 over c minus 1. And again, keeping in mind, just like yesterday, we can't cancel those c's out. It doesn't work that way because we've got that 2 and that 1 subtracted from it. And you're done. Okay. So B, we've got m squared minus 16 over m plus 2 times 1 over m plus 4. Factor what we can. The m squared minus 16, it's a difference of squares. So that factored is m, square root of m squared is m, square root of 16 is 4, so that's m minus 4, m plus 4, over m plus 2, times 1 over m plus 4. Nothing can be factored from any of those. I've got an m plus 4 and an m plus 4 in the numerator and the denominator, so those would divide each other out. I'm left with m minus 4 times 1, so that's just m minus 4, and m plus 2. That's your solution and you are done with that one, with those two examples. Okay, so it really does become about factoring and then reducing those pieces within those factors. Okay. Second objective then is to find reciprocals of rational expressions, and this really leads into how do you divide. Okay, so we want to find reciprocals of rational expressions. Why do we need to find it? To find the reciprocal of a non-zero rational expression, just invert the rational expression. Okay, so if I have something like 1 over 2, the reciprocal of that inverted is 2 over 1. If I have x squared over 6, 6 over x squared is what it is inverted. They're not equal to each other. I shouldn't have an equal sign there. But they're just inverted. And we're going to need that when we talk about dividing rational expressions. Okay. To multiply, top times top, bottom times bottom, reduce, do all of those things. When you divide rational expressions, you are actually going to divide two rational expressions. You're going to multiply the first, which we call the dividend, by the reciprocal of the second, which we call the divisor. So we're going to change it from a division problem to a multiplication problem by multiplying, changing the division to a multiplication, and then the second one only, you're going to invert it, or it's reciprocal. So let's look at two examples. So we're going to divide. The first thing I like to do when I do these is I rewrite it as a multiplication question first. Okay, so 5p plus 2 over 6 divided by 15p plus 6 over 5. So step 1, the first is going to stay exactly the same. Leave it alone. Now we're going to multiply by the reciprocal. So 15p plus 6 over 5, the reciprocal of that, so inverted, is 5 over 15p plus 6. Now we've turned it into a multiplication problem. Now we go back to what we just talked about when we're talking about multiplication. We look to see if any of them can be factored. Okay, for the first one, 5p plus 2, nothing can be factored. 6, obviously nothing can be factored. 5, nothing can be factored. 15p plus 6, they have a common factor of 3. So this time I'm just going to write it underneath it. So if I take a 3 out of there, 15 divided by 3 is 5. So that gives me 5p plus 6 divided by 3 is 2. So now if you'll notice, I've got 5p plus 2 in the numerator and 5p plus 2 in the denominator. They're going to eliminate each other. Nothing else eliminates, so on the top I've got 1 times 5, or 5. In the denominator, I've factored that, so that's kind of gone. I've got 6 times 3, which is 18. And that's my solution. And we're done. So division, rewrite it first as a multiplication problem by changing it to multiplication and inverting it. Then factor out any piece you can. Cancel out any things that like on the numerator and the denominator. And then multiply top times the top, bottom times the bottom. Okay. So I'm going to rewrite this one. So let's look at B. We've got q squared plus 2q over 5 plus q divided by 4 minus q squared over 3 times q minus 6. So I'm going to rewrite it. It's q squared plus 2q over 5 plus q. And you've seen the little for me right there. I think we're going to get an opposite in here maybe. Division becomes multiplication. And now we invert the second one. So 3q minus 6 is going to go in the numerator. And 4 minus q squared is going to go in the denominator. Now we need to factor everything that can be factored. So q squared minus 2q, 2 terms, GCF is q. And then that's q plus 2. Nothing I can do with the 5 plus q, so I'm just going to rewrite it down. Times 3q minus 6. They have a 3 in common, and that leaves me with q minus 2. 4 minus q squared, that's a difference of squares. So that's, oops, sorry. The square root of 4 is 2, square root of q, so 2 minus q, 2 plus q. Now you'll notice, see if we can cancel anything out. You'll notice that this q plus 2 and 2, they're opposites of each other. So really this can become -1. And you'll also notice that these are opposites of each other. So this can become -1 as well, and those will cross each other out. So now on the top, we've got a q times -1 times 3 times -1. So -1 times -1 is positive, times 3 is 3, so we've got 3q on the top. And if we look in the denominator, we have 5 plus q in the denominator. And that's your solution to this. Okay. And again, I have tried to, in most cases on your assignments today, to kind of get rid of that opposite thing a little bit. It might show up occasionally, but I've tried my best to make sure that you don't have those with those. So there are their answers. Okay. That's adding and subtracting. So this is your second lesson. This was 7.1b. Make sure when you're doing this that you factor everything that can be factored. And then if you can reduce, and then top times the top and the bottom times the bottom. And when you divide, you change it to leave the first one alone, change it to multiplication, and then it's reciprocal. So that does it for section 7.1.